All right. Hey guys. So in this video, we're going to be going over the instructions for the force on the charge PhET activity. Just kind of give you an overview of where we're at so far. So you guys have gone over last week all of the different types of charging and different forms of charging. And so we're going to kind of link that together now. We already know that, opposite charges attract each other, like charges repel each other. So now we're going to take a look at the math relationship between them, which is something that we've done before in class. So hopefully you don't have too hard of a time doing this. So to start us off, I fixed together a little slide for us. And on the activity itself, you guys are going to have an investigative question. And so that investigative question I listed right here. And the question is, how do distance, charge, and the charge sign affect the force acting between two electrically charged objects? So your guys' task is going to be to determine this precise relationship between the three things that I just listed: force and the distance between the charges, force and the charge, and force and the charge sign. Okay, so I have some charges right here. It's going to look very much like this. And just some useful info. So the measurement of charge is performed in coulombs. Okay, 1 coulomb is actually a very large value. A lot of times you're going to see things listed in microcoulombs and nanocoulombs just because the value of a coulomb is so big. You're also going to see the variable Q used. I know that in the past we used Q to represent heat. In this context for electricity, Q is going to represent charge, which, if you kind of think about it, that kind of makes sense because, heat will travel through a conductor, right? We use those same words, conductor and non-conductor, right? Insulator. And electricity does the same thing. Electricity travels really well through a conductor and not very well through an insulator. So it kind of makes sense that they use the variable Q again. So, let's go ahead. Let's take a look at the activity. I have that right here. You're going to notice a couple things. So I have the table of contents in case you guys want to jump between sections. So we have the beginning, we have the investigative question that I just listed to you guys, and then we have the conclusion at the very end. Okay, let's go back to the investigative question. So in the investigative question, you guys are going to take the time to answer it. So what do you think? How do you think that distance affects the force between the two charges? How do you think the value of charge affects the value of force between charges? How do you think the sign of the forces, positive or negative, affects the force? Okay, so you guys are going to take the time and you'll use this space right here to write a 1-sentence or 3-sentence. You can make a bullet list if you'd like. Claim on how those things affect the force between two charges. Some evidence, you can just use evidence based off of the scenarios, the lectures that we did last week. You can use evidence from real life, whatever. And then reasoning will just be your section to elaborate. Okay. All right, so go ahead and once you get there, you'll click on this link right here and it's going to bring you to this simulation. Okay. This simulation should look extremely similar. And the reason it looks extremely similar is that this should remind you of the lab that we did on universal gravitation. I'm almost thankful that they did it in exactly the same format, and you'll see why in the future. So you'll notice here's our Q1 right here, Q1 for charge 1 and Q2 for charge 2. They have the values of force listed up here, okay? And they have the values for charge right here, okay? Just kind of a reminder from when we did unit conversions, this little u stands for micro, 10 to the negative 6. Just recall that I said that 1 coulomb is an extremely large value. And so when you have a microcoulomb, that kind of puts things more into realistic terms. A microcoulomb is a sensible value. And so, yeah, that's about it. The only other thing that I have to show you guys on this simulation is that you'll notice that this is a 10 centimeter stick. And you'll notice that the spheres, they are centered on the measurement. So currently these two spheres are 1, 2, 3 centimeters apart. One last feature that you guys can take a look at is the ability to turn things into scientific notation. If you're more comfortable in working in scientific notation, that's great. You can have that on. If you don't feel comfortable working it, you can have it like this. Just know that if you're not working in scientific notation, then you could end up getting a lot of zeros or some very big numbers that you're working with. Okay, so looking back at the simulation, we'll go and we'll take a look. So the first one, you're going to be varying charge 1 while holding charge 2 and the distance to be constant. What you guys are going to do is then list the force, and you're going to list what direction is the force. Are they going towards each other? Are they attracting each other, or are they repelling from each other? For the part 2 procedure, you guys are going to be changing the sign. So you'll notice that in the very first one, they had opposite signs. Down here, they're going to have the same sign. And I kind of actually gave you a little bit more help, but I'm going to expect you guys to, fill in the table for me. Again, you're holding charge 1 constant, you're holding distance constant. You'll write down what is the force, and then you'll write down what is the direction of the force. Is it inwards or is it outwards? For the part 3 procedure, you guys are going to be holding all of the charges constant, and you're going to be playing around with the distance between the two charges. Again, you'll list the force and the direction of the force. Okay? So it should be pretty straightforward. You'll come down to the conclusion once you've done, and you guys will answer the following questions. So how, if you did increase the charge of one sphere, what happened to the force between them? This is where you'll write that in complete sentences. If both charges had the same sign, how did that compare to when they had opposite signs? If I changed the distance between the charges, how did that affect things? And then for question 4 and 5, I'm going to have you guys graph some stuff. I want to get us back into doing that, and that's why I'm going to give you guys the 2 days to do this activity. So I do want you to go back to part 1 procedure, and I want you to graph force versus the value of charge 1. Use Google Sheets, use those meatballs, copy and paste the image into here. And then I want you to go and look at the part 3 procedure. I want you to graph force versus distance, again using Google Sheets, copy and paste the image right here. Okay. Once you've copy and pasted the images, I want you to look at the images. And I want you to answer and ask yourself, what is the mathematical relationship between those variables that you just graphed? So for number 6, it asks you, what's the relationship between force and charge? Is it directly proportional, inversely proportional? Does it follow a different relationship? And then the same thing for force versus distance. You'll notice that for both of these 2 questions, 6 and 7, I gave you guys a link. You can click on that link right here. And this should look actually kind of familiar. We've used it before. It gives you the, what if y just equals to a value? Okay, it only has a y-intercept. It gives you here's your directly proportional graph. Here's your inversely proportional graph. Here's your exponential graph. Here's your y equals to the square root of x graph. I give you these 5 graphs because it's going to be one of those 5 graphs. I just want you to let it help you in determining what that mathematical relationship is. Okay. Once you've done that, we can go ahead and we can put it all together, put our puzzle together. So you'll notice that in question 8, I asked you to write a 1-paragraph conclusion of all this. So what was the answer to the investigative question? Okay. Let's go back and look at the investigative question. Investigative question is right here. Okay. Was your prediction correct? don't go back and change your prediction. That's not good science. It's okay to be wrong. I'm not going to mark you down if your prediction was incorrect. Hopefully you had a good idea of what to expect, but if you made a mistake, that's fine. And what are the math relationships between them? Okay, so we're going to be using this information once you guys have finished the 2-day activity to put it all together, create an equation that describes the relationship between force and these variables. And then we'll be able to do some calculations based on them and just kind of play with the concepts from them. So let me know if you have any questions. Again, I'm available at office hours, and yeah, that's it.